This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the 2015 season of the Math Ed Podcast. I'm excited to be back for another year, and I'm also excited to have with me Bill Zahner, who was actually the first ever guest of the Math Ed Podcast back in episode 1201. Bill, thanks for coming back.
Wow, well, thanks. I'm happy to be here, and thanks for having me. And I'm honored that I got the second invitation.
Bill is now an assistant professor at San Diego State University and a member of the Center for Research in Mathematics and Science Education. We're going to be talking about Bill's new article in Educational Studies in Mathematics, The Rise and Run of a Computational Understanding of Slope in a Conceptually Focused Bilingual Algebra Class. So, Bill, this article really focuses on Miss V's algebra classroom. So I was wondering if you could just tell us the story of how you became so interested in Miss V and what it was about her classroom that led to you focusing this study on her class.
Well, so the background is that this is growing out of my dissertation research. So this article is published out of the data that I collected when I was a graduate student at UC Santa Cruz. And when I was a graduate student, they had us do what was called a second-year project, a research project. And my interest was in how students talk to each other during group discussions. And so I went out to a local sixth grade classroom in a bilingual school and recorded the sixth graders talking about math. And what I found out was that when kids are given routine calculations to do, they spend a lot of time talking about long division. And that wasn't exactly what I was looking to observe. I wanted to see examples of how students engage in mathematical reasoning. So fortunately, that was a relatively low-stakes event. That was a project I did as a student. And for my dissertation, I took the lesson that I learned, which was I needed to go see a location where the phenomenon I wanted to observe was likely to happen. And so I was interested in students engaging in mathematical discussions and doing things like reasoning and sense-making. And of course, now we talk about these perhaps in terms of the Common Core State Standards and the Standards for Mathematical Practice. So I wanted to see those kind of things happening in real mathematics classrooms, and particularly with linguistically diverse students. So I did some investigation asking around with local teachers and teacher educators to find who was doing those kind of practices in their classrooms. And people recommended Miss V. She came recommended very highly and actually had a very strong reputation, both locally and nationally. She's been on a number of boards and so on. So that indicated to me that she was a teacher who was likely to be doing the kinds of practices that I wanted to see, and that her students would be doing those as well. So that's what drew me to her classroom, and I was also interested in the issues of language and language diversity. And so by an ad hoc arrangement, her classroom was a bilingual classroom, where she taught all the newcomers, the students who had immigrated from primarily Mexico, but also Central America. And she would teach in both Spanish and English, or she could teach in both Spanish and English, I should say. And so through an informal arrangement, the scheduler put many of the students who were enrolled in the English language development course, so the newcomers, into her math course because they were able to then continue their math education using their first language as a resource. So that was a second reason I chose Ms. B's classroom.
So you've identified this conceptually focused bilingual algebra class, and then you focused the study on the mathematical topic of slope, which is, of course, a very important topic in algebra, but also beyond algebra. So you're looking at slope and how the students' understanding of slope developed throughout kind of a unit that was focused on slope. And then you were looking at that student development, but also tying it to the actual things that were happening in the classroom, like the kinds of discussions and the kinds of activities or mathematical practices that the students were engaged in. What was the data you collected to be able to kind of track those things that you were interested in?
Yes, boy, just hearing you talk about what I did makes me think that I was crazy. So my goal, was to trace in a sense, the development of students' understanding of slope as a rate of change, and connecting the slope of a line to the rate of change of the variables connected by the function. And so that was kind of the overarching goal. And so to do this, it was a mixed method study. So I shouldn't say mixed methods in the sense of I didn't do any kind of quantitative assessments, but I mixed ethnographic observations of the classroom. So sitting in the back of the classroom and letting Miss V kind of do her thing. So I wasn't intervening in the classroom. But instead asked Miss V, when do you teach these important concepts? And can I come in for during that unit and watch the whole unit from start to finish?
Right.
And so in the classroom I had 2 video cameras running, and I was sitting in the back taking field notes, and occasionally another graduate student was there with me helping out, also taking field notes and keeping track of what was happening in the class, who was there, what they were talking about, and if anything particularly interesting kind of jumped out at us, we made sure to make notes of that and cross-reference the times. So we had 2 video cameras, and both of them were focused on groups of students sitting in the classroom. So Ms. B's classroom was arranged, as some math teachers do, they have pods of tables. So she had, I think, 8 pods at her room, 7 were occupied, in groups of 4. And so 2 of those groups were the focal groups for this study. And one of them happened to be 4 students who spoke primarily English in school, and one of them happened to be 4 newcomers who spoke primarily Spanish. And Ms. V put those groups together. So the cameras were focused on the 2 groups during small group interaction, and then I was sitting next to one of the cameras so that during whole class interaction I could record what she was doing on the board, or what whoever was speaking was doing up in the front of the room. The other data I collected were a series of group discussions that occurred outside of class. So I took those 2 focal groups of students, and I wanted to trace the development of their understanding of the slope as a rate of change. And to do that, I needed to give them the same tasks, or I wanted to give them similar tasks at the beginning and at the middle and at the end of the data collection to really trace how their reasoning about slope developed across time. And so one of the tasks I used is a classic that I'm sure many of your listeners are familiar with. It's called hexagon desks. Or also hexagon chains. It's been used on the NAEP and I think the Balanced Assessment Project and many other places where you have a series of hexagons pushed together, and the question is, if one hexagon has a perimeter of 6 and 2 hexagons pushed together has a perimeter of 10, continuing the pattern, what will you get with 3 hexagons together with a perimeter of 4, 5, and so on. And so I gave the students a group of 3 tasks, but one of them that I gave consistently was hexagon desks. It's called hexagon desks because it was stated in terms of the number of students who could sit around a hexagon table or a chain of 2 hexagon tables pushed together. And the task included multiple representations, so tables, graphs, and equations, and different types of generalizations. So asking the students to generalize to a low number that they could count to, and then asking them to generalize to a high number, like what would be the number of students who could sit at a chain of 100 desks. And then I asked them to create a function, an equation out of this. So I said to write a general equation in terms of n desks. And then finally said, if you plotted those and you connected the dots, and I had a little hedge, didn't quite put it into the thing for the students, but said you could connect the dots and make a line, although we know that would be actually a discrete graph. But if you did connect the dots and make a line, it looks a lot like the lines they were doing in their algebra class. And then ask them, what would be the slope of that line, and how would that connect to the problem situation? So that task provided me some really good evidence of how the students' reasoning about the slope as a rate of change developed across time, because the question asked them not only to calculate the slope, but then also to explain the meaning of the slope back in relation to the problem context, which was students sitting at a row of desks. And so, one possible answer might be that the slope is 4 because when you add 1 new desk, there are 4 new available spaces. So I collected that data at the beginning, middle, and the end of the classroom observations, and my goal was to trace the students' development of their mathematical reasoning across time, looking at both the nature of the answers they gave, and then also the kind of reasoning that they engaged in, both as a group and individually as they came to agreement on these solutions. And so for this paper, I'm really focusing on the type of answers that they produced and then looking to connect that back to the classroom data. So to make a connection between what they did in those small group discussions and what happened in the class where they were learning about these concepts.
Mm-hmm. And to tie it all together, you used the cultural historical activity theory, or abbreviated CHAT. So the CHAT framework helped you to do this goal that you just stated, and it also brought in a broader context of kind of the school community. So could you say why you ended up using the CHAT and how it kind of helped you achieve your goals for the study?
Oh, sure. So that was, I think, an interesting evolution in the study. So originally, I think my framework was more along the lines of looking more narrowly at the interactions within the classroom and what happened in terms of the development of the student reasoning about slope. So that was initially my focus. And I would say that the big conundrum that popped out at the end was when I looked at the development of the students' reasoning, what I observed was that they were able to calculate the slope on this problem and on many problems in class, especially when there was no context. But even with context, they were able to pull out the slope of a line by selecting 2 points and kind of going through this computational routine of finding the rise, finding the run, and putting that into a fraction. But interestingly, that wasn't Ms. V's stated goal for the unit. In fact, she really wanted her students to be able to articulate a meaning for the slope. And so there was a mismatch between what her students appeared to understand at the end of the unit and what Ms. V was hoping her students would understand. And at that point, I was faced with a little bit of a conundrum. So one interpretation is the students just didn't get it, or Ms. V must have made a mistake in how she presented the material. But I felt like there was more going on there, and from my ethnographic observations, I had a lot more data about the situation, the school, and the context, and the broader picture. And that's where the cultural historical activity theory came in. So you can look at individual reasoning or even a group reasoning by focusing on the people, the subject, and the object and goals of what they're working on and what their intended outcome is, and the mediational means that they're working upon or working with, whether it's graphs or calculators or what have you. Mm-hmm. But CHAT attempts to get beyond the individual or the core situation of the subject, object, and mediational means and says, sure, that's happening, but it's happening within a larger context and a larger social milieu that includes communities and rules and division of labor. And so to understand what's happening within this micro interaction, whether it's happening, moment to moment or even across a couple weeks, it's also helpful to look at the broader community, the broader rules that are governing the situation, and how labor is divided up among the students, between the students and the teacher, and then even looking even bigger at the teacher and the school and the district and the state and so on. And so cultural historical activity helped me make sense of how Ms. V's teaching was in several important ways shaped by what happened at the broader context of the school level and the district level. So that's where the CHAT theory came in, was in a sense by looking at my data and saying, I'm not quite capturing the complexity of this whole situation just by looking at the students' interactions, at the beginning and at the end of the unit and looking into the classroom. And I need to have a broader viewpoint, kind of zoom out a little more to understand exactly what I observed, or to make better sense of what I observed, I should say.
My guest is Bill Zahner from San Diego State University. We're talking about his article in Educational Studies in Mathematics, Volume 88. Bill, now I'm wondering if you can just talk us through when you looked at those student groups, when you pulled them out to actually kind of trace their slope understanding, what did you see in terms of their talk about slope?
So I'd say that one of the main clear findings was that the students were able to calculate the slope of a line by the end of the unit. So if the goal was for the students to produce correct answers, then this class was a success. The students were able to take a problem, given 2 points, compute the slope of the line, or given the graph of the line, compute the slope. So in that sense, they were successful. In another important sense, though, they struggled to interpret the slope as a rate of change. And the evidence for that was both their responses to the hexagon desks problem, where one of the questions on the task said, what is the meaning of the slope of the linear model in terms of the situation? And then on a subsequent question, which I don't talk about so much in the paper, but a subsequent task was a distance time graph, and both groups really struggled to make sense of the slope of a distance time graph in terms of velocity. So that indicated to me that although this class was successful in some important ways, there were also some important disconnects going on. What I also noticed when I looked back into the classroom data was that there was a pretty significant shift in Miss V's teaching about a week after she introduced the idea of slope. And so I traced through the classroom data and looked at how Miss V's talk about slope and rate developed across the couple weeks when she introduced it. So initially, Miss V introduced the idea of slope using applied problems from IMP. And these are problems where, for example, the students are given data about how far a group of people have traveled over a certain number of days, and then they're asked to talk about the meaning of the slope. And so what I noticed at first is that Ms. V was constantly highlighting ideas like the amount of y per x. And one of the problems that I think I cite in the paper is an equation y equals 12.5x, where y is the number of pounds of beans that they need for the trip, and x is the number of people in a group. And she really emphasizes that the 12.5 times x, the 12.5 indicates the amount of beans per person, or how much beans each person is going to consume across the trip. So that was the initial way that she introduced slope. And then I noticed a pretty radical shift about a week later. And in that shift, Miss V transitioned to using problems that really had almost no context. In fact, some of them were photocopied pages of the old algebra book that I used as a student, so I was quite familiar with it, where you're just given 2 points, find the slope of a line, or given a graph, calculate the slope. So that really jumped off, as a researcher to me. I said, wow, something odd is going on here. I need to understand what's happening here. And I want to understand why Miss V is making this sudden shift. And so that's where there was an interesting shift happening in both the classroom discourse and I think in what the students were then taking away from it. And I wanted to trace that and understand that a little bit better.
So in reading the paper, you give these examples of once there was this kind of almost curricular shift to these different kinds of problems that she was bringing in. Then you noticed these words, rise and run, became very important. Can you tell us a little bit about what you saw with those words coming into play?
Yes. So, and I titled the paper "The Rise and Run of a Computational Understanding of Slope." I don't know if it's a pun or not, but you can think of it rising and continuing in the class. And of course, in traditional math books or mini math books, we equate slope with rise over run. And I had a conversation with Ms. V where she said to me explicitly, I absolutely hate rise over run. I don't want my students using that expression because she felt like it minimized the conceptual meaning of the slope. And so she was really wary of introducing a calculational routine too soon because that would be what the students would take away. So what was fascinating to me was that some of the students, of course, this is ninth grade, and some of these students have already taken algebra or pre-algebra or courses where slope has already come up. So they have older siblings. So they all knew, or not all of them, but several of them knew the expression rise over run. And Miss V would always revoice that. She'd always say, rise over run, do you mean the amount up and the amount over? So she was trying to highlight more about what it was actually telling you about the graph. But still staying on the level, I would say, of connecting to the physical movement on the graph, rather than the conceptual meaning of the slope as a rate of change. And so there was this shift, especially when the problems were not the applied problems from IMP, but these decontextualized problems. Because, of course, in a decontextualized problem, it's difficult to put the meaning of the slope back in, right? I mean, if you talk about each 1 unit change in x, there's this much change in y. That's not necessarily a very relatable way to explain this to a newcomer, to a person who's new to the topic. And so I think there was a real tension there. And that's, in a sense, the fundamental tension that I felt in this kind of contradiction was Ms. V's desire to highlight the conceptual meaning of slope while simultaneously feeling the need to make sure that her students could do the calculations so they would be successful on the upcoming district benchmark test. Mm-hmm. And so that's really, for me, a sense where the light bulb went on when I said, what's going on here and why is this shift happening? Here's a teacher who has stated she wants to teach conceptually, who I know can teach conceptually, but who appears to be kind of turning on a dime halfway through the unit and shifting into a real procedural approach to teaching this content. And I was trying to make sense of that shift. And so that was where I saw the broader context coming in very clearly, and also where I saw a connection to an idea that I read about in graduate school and thought about, but then hadn't come back to in a couple of years, which was the idea of what's called boundary objects. And boundary objects are not exactly out of chat theory, but they've been used in chat studies as a way to think about how different activities and systems interact. And so that was kind of my next step in the evolution of my thinking was, okay, how do I understand this shift in Ms. V's teaching and the apparent contradiction in what her students are learning between what she said she wanted to teach and what it appeared her students had taken away. And that led me to thinking about the boundary objects as a way of understanding that.
Yeah, so which boundary objects kind of gave you the most sort of mileage or the most insight into what you were interested in?
So probably the most important one was the district benchmark tests. And I think that this is a fairly common thing, particularly in schools that are considered, and I don't like using this terminology, but there are schools that are either considered failing or considered underperforming. There's lots of different words that we use in the bureaucratic education world to describe these schools. And so the school where Ms. V taught was one of these schools, where the students had not met the state-mandated requirements for the high-stakes assessments. And one of the responses to that reality is that the school was then called a program improvement school, and there were serious sanctions that were threatened, everything all the way up to the school being taken over if the students' test scores didn't improve. And there were also actions taken, and one of them was to supplement the curriculum with a series of what they called benchmark tests. And so an external consultant had given the school a series of tests that were supposed to be administered at the end of each unit to give the teachers kind of the information they needed to develop their instruction around what was going to be showing up on the eventual spring tests, the statewide tests. So the benchmark test that was coming up at the end of the unit, when I took a look at it, and in fact I think I have a copy of it in the appendix of the paper, the benchmark test was really a series of just rote calculations on problems with no context, or I shouldn't say rote, but bald calculations on problems with no context. So although Ms. V did not explicitly mention the benchmark test as shaping her instruction, it certainly appeared that what was on that benchmark test reflected or had a strong parallel to what happened in the classroom in the weeks leading up to it. And so that's where I see this boundary object happening. So the benchmark test is a boundary object in the sense that it coordinates actions across levels of activity. So within the classroom, there's one level of activity, and then within the school and the district is a different level of activity. And here the same object played different roles for different groups. So in Ms. V's class, it was going to be the end of the unit test. But for the district, this was going to be also their assessment of, is this class on track to produce students who are going to pass the test, the statewide test. Yeah. And so the same object was serving different purposes. Very often we see descriptions of boundary objects in the literature thinking about them as facilitating communication across different practices, groups of scientists and citizen volunteers, for example. And in this case, it certainly facilitated interaction, although I wouldn't necessarily say in ways that were intended for all parties. So it's it's unfortunately not a story that is as happy as I'd like it to be, but I think it's also an important story, and becoming more so, I think, as more and more states and schools are adopting this idea of benchmarking their performance. And it's worth kind of thinking about what happens when you do that, and what do you choose for your benchmarks, and who gets to choose that, and what's the process for that.
Mm-hmm.
So that was one of the really important kind of implications of this case, is it illustrates a case where the benchmark test shaped the students' opportunities to learn in important ways, and appeared in some ways to really inhibit the depth of their conceptual development about slope, because there was a huge emphasis on developing this procedural fluency and assessing that alone. It's interesting to imagine, what if the benchmark test looked more like the IMP problems? How would instruction look different then?
Mm-hmm.
And of course, it's easy enough to imagine good and bad scenarios, right? But it's an interesting kind of thought experiment to kind of play through that idea.
Mm-hmm. You mentioned it wasn't, the happiest story that it could have been, but on one end of things, if your goal is the procedural fluency, and if that's what you're all about, then this is kind of a happy story, because it sounds like Miss V was pretty successful in bringing a lot of students to have success on the procedural side of slope. It just becomes a sadder story if your goal is really for the conceptual side, which, as you said, it was your goal and why you're interested in these things, and it was Miss V's goal. And so then it now becomes this, more of a tragedy.
Yeah, that might be. I hope we're not overstating it. I think these are not like irreversible situations,
No.
and many of us have probably had years of different types of math instruction and come out with understandings in the end. But I do, I see some interesting parallels. There's a Schoenfeld article named "When Good Teaching Leads to Bad Results," and I think he makes the point too that what students learn in a class, and whether or not that is what we want them to learn, is a really important thing to pay attention to. So students who might look competent at producing answers may not be developing the types of mathematical reasoning skills that we are hoping for. And again, you're now thinking about our current climate, in the CCSM kind of aligned world. I think that we're really hoping for more reasoning and sense making, and increasing that focus. And having students engage in these mathematical practices. So it is true that Ms. V students develop this procedural fluency, and that is, as the NRC's adding it up has, kind of that framework of mathematical proficiency. It's part of mathematical proficiency. But I was also hoping, and I think that there was some important stuff lost by not assessing other types of mathematical proficiency. Whether it's conceptual understanding or adaptive reasoning or so on. So giving the students opportunities to demonstrate that. And so that's where I think that one of the broader lessons about the design of these benchmark tests and so on is a really important consideration. And I fear sometimes that these assessments are produced outside of the realm of control of the teachers who are trying to reach some goals. And if there's a mismatch between the teacher's goals and the assessment, then in the end, I think the assessment basically trumps, particularly as we add higher and higher stakes to these assessments. So, for readers of the article, one of my theoretical goals was to connect the macro level policy and what's happening with the education for students, like the students in Miss V's class, to what happens on student learning. So what kind of opportunities to develop an understanding of the mathematics are made available to the student. And so that's where I hope is one of the big takeaways, that these decisions about assessment and about how often we assess and where and in what form and for what purpose really do influence what happens in the classroom and really influence what students are going to eventually end up learning. So also, I would say that there's some kind of silver lining on this too, and Alan Schoenfeld and his group has done a lot with the Mathematics Assessment Project, and there are many others who have done, I think, really great work on developing rich assessments. So like David Foster's group, also the Silicon Valley Math Initiative, developing really great assessments that give us more information about students' understandings, their procedural fluency, and their dispositions and so on towards mathematics and the ways that they engage in the practices. So maybe another takeaway kind of on the brighter side is that, well, what can you do? And I think these are some of the good resources that are out there for teachers and curriculum developers and educational leaders to look at and think about how assessment can be more than simply taking the temperature, but actually doing part of the work of instruction as well. So that's not necessarily in the paper, but when I think about one of the implications, that's how I kind of see this playing out, and what I tell teachers when they ask me, okay, so what should I do? Because I think it's an important issue to address.
Mm-hmm. Bill, thanks so much for talking to us about that study. I do want to ask you a more personal question. I asked you before, back in episode 1201, about your kind of alternate career, so people can listen to that if they're interested in what you would have done if you weren't in math ed. Now, because you're resettled over on the West Coast back in California, I wanted to ask you what it is that you've kind of enjoyed the most now about being back in California or back in the Southwest.
Oh, sure. So I am just recently relocated from Boston to San Diego, and I have to say that I really miss my colleagues in Boston, and my students and colleagues at Boston University were really a great place to be, and miss them all dearly. I'm really excited to be back in California to be closer to family. So both my wife and I are from the West Coast originally. So I have to say, hands down, the most important thing for us is having that proximity to family and the opportunity to be nearby. And then I probably shouldn't say this, but it's really nice to be able to wear a short-sleeved shirt in January. But you can probably take that out of the episode.
No, that's all right. People need to hear that, I think.
I'll say too. I'll just add one on a more serious note. I'm also really excited to be at Crimsey at San Diego State and to have such wonderful colleagues here, and great opportunities to continue my work with issues of language and language diversity in mathematics. And of course, San Diego is a great place to do that. We're right on the border and have essentially an international city here, and it's a really interesting place, both in terms of our connection with Mexico and the Tijuana area and kind of the whole region, and then also the city of San Diego itself is also a magnet for immigrants from all over the world, and so having the diversity here is a really great opportunity from both a research and teaching perspective to affect the education of many students, and so that's a real honor and a pleasure to be here. It's a pleasure for me to be here.
Mm-hmm. Well, it was a pleasure for us to have you on the podcast. Thanks so much, Bill, and have a great semester.
Well, thanks, Sam, and you too.
Thank you for listening to this episode of the Math Ed Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.